Okay, now that we've spent a bit of time digging through the XNA framework and tracing through how a very basic XNA game runs internally, let's go ahead and spend a few minutes and create an XNA game from scratch. What I'm going to have Logan do is create a new console application and turn that console application into an XNA game. The interesting thing about this is, one, you get to watch it getting built up. Two, you're going to see just how important that content pipeline is to us. So Logan, let's go ahead and begin with a new console app.
Okay, we'll start at the very beginning, a simple console application. I am going to give it a name from the start because I'm going to need to refer to this project later when we have to start dealing with assets.
Okay.
So for the name, I'm going to call this XNA Scratch, and that'll be our project name.
All right, so of course we start out with a very simple console app which just has our program C# file. Let's go ahead and add a new C# file and make it look sort of like the XNA game with a game1.cs file.
Okay, we could go to the project and add a new item, and this item will be a class called game1. So now we have a program.cs class and a game1.cs file.
So over in the Solution Explorer, it's looking a little bit more like a Windows game. All right, so now next thing, I'm looking at all of these using statements. We've got system collections and generics and text. We're not going to need that, so we can go ahead and get those out. And before we start adding the Microsoft Framework namespaces in, we're going to need to add them as a reference for our project.
Right, we need to add the references to the actual XNA assemblies. So to do that, we'll come back over to our Solution Explorer, over to References, and we'll go to Add Reference. From here, what we're looking for is Microsoft.xna.framework and framework.game, because we are, of course, going to need the game class in order to make our new game. So I'll include both of these assemblies as references. And with these references, we should now have access to their respective namespaces.
All right. So let's go ahead and add in the Microsoft XNA framework.
So Microsoft.xna.framework.
Okay.
And there we go.
Okay, now let's go ahead and turn our attention to the class Game1. We know from the last lesson that Game1 extends game, so let's go ahead and inherit from game, as game is found inside the XNA.framework namespace. Okay, very good. So, that's a good start. I mean, at this point, you should be able to go ahead and build. Heck, we can even run and watch a real quick flash of a console window. Not exactly what we're looking for. We're looking for that cornflower blue window. So what do we need to do next? Now we can go ahead and start focusing on adding some fields in and the constructor and just slowly start building this XNA game up. So we know the two fields that we're going to need are going to be, right off the bat, we're going to need graphics and we're going to need content. So we need a graphics device manager and a content manager.
Right. And just to match the default template naming, I'm going to name them graphics and content for the graphics device manager and the content manager.
That makes sense.
Let's begin with graphics. So we could say that we have a graphics device manager called graphics.
Now this is interesting. Yeah. Now the graphics device manager resides, of course, in Microsoft.xna.framework. But now you're going to add in this content manager. Go ahead and type it out.
All right. So content.
Didn't tell us sense. It's not there.
Manager. Nothing there, and nothing seems to highlight.
Yep. So in this case, we're going to need to add up to our using statements using Microsoft.xna.framework.content.
So if we add on to the namespace the content namespace, then look at that. Content manager is now a recognized type.
Very nice.
So we can make a content manager called content.
Now, of course, if we were going to continue building this application just as we would a regular templated Windows game, XNA game, we would generally add a sprite batch next if we were going to do any sprite batching in our game. Let's go ahead and do that, just so that they can see that we're going to need to add in the framework.graphics.
Just since sprite batch is what we've been using to demonstrate drawing all along this far in XNA, we know we're going to use it, so we're going to go ahead and add it right off the bat.
Exactly.
So we're going to make a sprite batch field. But now sprite batch seems to not exist.
So we need to add it in, yeah.
So we need to add on to the namespace the graphics namespace. So Microsoft.xna.framework.graphics. And then there we go. Sprite batch is now recognized. So let's make our sprite batch field simply called sprite batch. And there we go. Now we've got fields for all of the different things we need to manage and draw content.
Okay. Now, of course, the next thing we're going to need to do is get a constructor in place so that with the constructor we can go ahead and create the graphics device manager and the content manager as well.
All right. So let's jump down below the fields and make a public constructor for our game1. So we can do public game1. And inside of the constructor we want to create a new graphics device manager and a new content manager. So that means graphics equals new graphics device manager. Now, the constructor to graphics device manager is going to take in a reference to a game. What game is it associated with? Well, as game 1, we are a game, so we can feed it this as the parameter.
Feed it ourselves.
Next is the content manager, so we can say content equals new content manager. Content manager is going to take in what they're terming an iService provider as the parameter. We have access to that under our own game class, so we can do this dot services will satisfy that parameter requirement.
Okay, so now that we are creating the graphics device manager and the content manager, we've got our constructor in place. Let's go ahead and turn our attention back over to the program C# file, and from inside here, let's go ahead and create a new instance of the game.
Okay, so inside of main, as soon as the program starts running, let's make a new game. Let's first declare a variable so we can control this game and tell it to begin running. I'm going to declare a variable called of type game1 called game, and we'll immediately initialize that to a new game1. So this will create a new game for us.
Okay.
Then I'm going to immediately turn around and tell our new game to run. And that's it.
All right, and right here, let's go ahead and build, and then let's run, because if everybody remembers in the trace in the last video, just that constructor in itself is going to push us all the way through to the creation of a form, a Windows form in memory, and then game.run is going to get us all the way through to host.run, which is going to start that application message loop and show our window. So let's go ahead and run real quick. And whoa, check it out. It's still a console application, so there's our console, but look what we got behind it. XNA Scratch. We do have our game window. This is very interesting to see. And not only that, look at this. Our buffer is full of garbage. Looks like I was running Houdini just a little bit earlier.
So yeah, we don't have any code or any override for draw yet, which means that the buffer is never getting cleared. It means any garbage that might have been in the buffer is being shown directly.
Exactly. So I don't know about you, Logan, but I think now's a good time to close this and head on over and override draw, and let's go ahead and clear that buffer out.
Alright. So alright, first thing to override, we'll override draw. So this is going to be protected, override, void, draw. I'll select the one out of IntelliSense. And now, the very first thing that we need to do inside of draw is to clear the graphics device. And I'm going to do that through graphics.graphicsDevice, and we can tell it to clear. And clear is going to expect a color in order to clear, so I'm going to give it the familiar color.cornflowerblue, just to mimic a default template-based game.
Sure. Let's go ahead and run again. And hey, very nice.
So we've cleared all that garbage out of the buffer, and when we have our own cleared buffer to the color blue.
Very nice. Now at this point, let's go ahead and change our project properties type, our output type. Let's go ahead and make ourselves a Windows application so that we can get rid of that DOS window or the console window that keeps popping up.
Sure. We can go up to our project and open up its properties. And from there, one of the first things we're presented with is output type, and it's currently set to console application. If we change this to Windows application and close out the property windows and run again, now we don't have any console window. It's
Very
expecting
nice.
this application to handle any interface itself, so it's not relying on a console window at all.
So very cool. Now, at this point, everything's hooked up, everything's running, but we don't have anything taking place in our game to demonstrate, update, and draw and have them actually functioning, other than the fact that we have indeed cleared out our buffer. Let's go ahead and close that, and let's start setting up to draw some sort of texture.
Okay. That's probably going to begin with creating the sprite batch itself. So in order to create the sprite batch, I'm going to override initialize. So we've got protected, override, and let me grab initialize out of the list. You'll notice IntelliSense filled in the word void that I omitted. It noted exactly how initialize needs to work and has it all set up for us. I'm going to jump above the call to base.initialize, and we can create our sprite batch. So this will be sprite batch equals new sprite batch, and sprite batch requires a reference to a graphics device, so we'll use graphics.graphicsDevice.
Okay, so now we need to go ahead and set up a texture 2D that can hold a texture that we can then have sprite batch draw.
And speaking of holding a texture, I'll probably need a field in order to hold and remember a texture between draw calls. So I'll go back up to our fields and I'll add in a texture 2D simply called texture. Alright, now we can focus on loading an asset in for that texture.
Exactly.
Now, I guess we could begin. There's two things we need to look at. Exactly how is this asset going to be handled as far as Visual Studio is concerned, and how are we going to go about loading it? I could skeleton in the method of load graphics content, because we know we're going to need load graphics content to get the asset loaded in. So we can put in an override to load graphics content.
Which everybody remembers, that particular method gets called from the base's initialize method.
And you'll also note that under the template game, generally the base isn't called.
That's correct.
Since it's assuming that everything that needs to happen will be done or will be provided by us. So I'm going to take out the call to base.loadGraphicsContent, though I am going to put in the if statement to check for load all content, because we saw how load all content was true if we were loading for the first time.
Correct.
So I'm going to put in the check for load all content so that we know we're loading, or that this is the first run of the app. And inside of here, we know pretty much what we need to do on the code side of things to load in a texture. We can do something like texture equals content, use that content manager to load in the asset. So content.load, we know we're loading a texture 2D type. Now here's where the question comes in. What do we load from? Because it's now expecting the asset name. In the past, when we were wondering what the asset name was, we would look to the Solution Explorer and find the graphical asset and just let it tell us the name. The problem is, where's the graphical asset? And of course, if you've been watching the last videos, you might be wondering why we're not just adding it. So let's try. Let's try to add a PNG file to this solution, or to the project. So if I go to Project, and then Add Existing Item, and we go to the type of file and drop this down, we're missing content pipeline files. In theory, we could find an image type that it might load. The problem is, we need the content pipeline in order to generate the asset that the content manager is looking for to load. Without the content manager integrated into this project, there's no way we can get the files build through the content pipeline.
Exactly. So let's go ahead and launch a second Visual Studio Express.
So what we're going to do is we're actually going to create a quick temporary game that has the content pipeline, just so that we can get a graphical asset generated, and then take that back over to our Scratch game. So in this case, we're just going to create a Windows game for temporary purposes. I'll leave the name to the default Windows Game 1. And inside of this, I'm not even going to worry about anything on the code side. Instead, I'm going to go directly over to the project and add an existing item. And I want to add a graphical asset, though. Let me back up one step, because I need a graphical asset to add in the first place.
That's correct.
Let me jump over to our working folder where I have this PNG file. This was the player PNG from the Canon 3 game. Let me copy that now over to the projects folder. Here's the project Windows Game 1 that we just created for this temporary game. Let me jump inside of it, and I'll drop the player PNG file at the same level as the project and the game icon.
Okay. After you load it, before building anything, go ahead and show them that even though you've loaded the asset in, that it's not yet actually generated an XNB file.
Sure. And where I'll be looking for that is in the bin folder, the actual output for this game. Because as we build and run the game, we should see the executable to the game appear under this bin folder. And we're also looking for the XNB to appear alongside it. So let's jump back to this temporary game now. And now let's add in the PNG file. So we can add an existing item, and then drop down to Content Pipeline Files, and there we go. Now we have the ability to load in a PNG file and have it processed through the content pipeline. Though, while it's loaded here, we haven't built yet. That means that if we jump back to our output, we still don't have any compiled asset. So let's run the game so that everything gets built. So this again just being our temp game. We can close it, but now check the output folder. Alongside the executable, we now have this player.xnb file. And this is the actual asset that the content manager is looking for. It's kind of cool to see the content data, or the compiled data, in a file form. Because up until now, we've just assumed that this is a magical asset and this name can be plugged into the content manager. When what's really happening is this name is used to build a file name looking for this XNB file.
Exactly.
So with this in mind now, we have a compiled asset. So we could copy this and move this back over to our Scratch game, though I'm probably going to need to save the project first so I have a folder to put it in. So jumping back momentarily to the Scratch project, let me do a save all, and I'll save it to a folder named XNA Scratch. Now we can jump back to the projects folder, And if we look at the root of the projects folder, we now have our XNA Scratch folder. And inside of that, let's see, we should have a bin and a debug, and there's our executable for XNA Scratch. So I'm going to paste this player asset right alongside the executable, just as it was on the output on the temporary game.
Okay.
Alright, now we know what it is we're loading. We know that we don't include the X and B because we're using the Content Manager, so we should be able to load in the asset named player using the Content Manager. So jumping back to the XNA Scratch project to our line where we're loading in the texture, let's load in the asset player. And now let me run the game and make sure that we get no exceptions on this line when we run.
Okay, and of course you're not going to see anything drawn because we haven't gone and started the sprite batch, did the drawing and ended the sprite batch yet.
But I can prove that this asset is required because if I name it incorrectly, like name it player 1,
now we got a problem.
Then as soon as we get to this line, we get an exception saying that the file player 1 could not be found.
So obviously the Content Manager did not have a problem loading player.
One other thing we could do is, in the past, in XNA games, we were organizing our textures into a textures folder. And there's no reason we can't do this for our Scratch game. If I wanted, I could go to the folder, our output folder for the game, and add a textures folder, and then simply move the XMB file into that textures folder. Now over in the Content Manager load line, I have to change this over to textures and give it the path, the relative path from the executable to the asset. Though, since we have a backslash and an unescaped character, I'm going to add the @ symbol so that we accept this entire string as a literal instead. So now I can run, and once again everything is running.
Okay.
And set up in a way to mimic the XNA games we've created in the past.
Exactly. So now we can go ahead and jump back over to the draw method and get it drawing.
Alright, and to do that we're going to need to address the sprite batch. We can first tell the sprite batch to begin, and then we can draw out that texture graphic. So we can say sprite batch dot draw, where we will draw the texture. For the position, I'm just going to give a vector2 of 0. So we can do vector2 dot 0 for the position, and then we're going to draw it with the color white, so that no change is made to the actual color of the graphic. And finally, we will tell the sprite batch to end, so that any graphics currently batched are flushed out and drawn, and now we should be able to run and see the graphic. And check that out.
Very nice.
An XNA game made entirely from scratch with graphical assets loaded and displayed.
Very cool. Now, just so that we can get update as part of the whole thing, let's go ahead and create a position field and then use that position field and update by updating it, and then use that over in the draw method.
Right, let's set it up so that that ship graphic moves now.
Yeah.
And before we jump out of draw, let me change the background color to black, since that graphic was from Canon 3.
Yeah, it'll look better.
And Canon 3 was drawn on a black background.
That's true.
So things will look better if we set it up on the proper background color.
Very nice.
Now, the next goal we want to see is how would we make this move, make the graphic itself move. And as you're saying, we could make a position value held as a field so that we can update every time the game's update is called. So let's define a vector2 field called position. And then let's draw the ship at the position vector instead of at the vector2.0. So now what we want to do is set up a scenario so that position gets updated by the game. And to do this, gives us a perfect opportunity to override update. So we'll do a protected override update, or there I go with too quickly hitting the first thing that began with the letter U. So override, protected override, void, update. There we go. And inside of update, all we want to do is take position and advance it. Let's say 2 units to the right and 1 unit down.
Okay.
So we could say that position plus equals a new vector2, where we move 2 to the right and 1 down, and that's it. So we have the position vector updating over time. So now if we run, we have an animated ship graphic.
Very nice.
And of course it'll simply move off the edge of the screen because there's no bounce code in place. But I mean, that does indeed show the texture being animated.
Not only that, we've now shown the creation of a full XNA game, albeit a very simple one, but we have built one from just a console application. So we've built it from ground up. And like I said at the very beginning, you were going to be able to see the importance of that content pipeline, as you saw that when working in an actual XNA Windows game, we have that content pipeline just sitting there ready to help us out by bringing content in that's supported by the content pipeline. And then at build time, the content pipeline takes that and just automatically gets it compiled into a binary format that's then able to be used by the content manager for loading and utilizing within our game. Very cool stuff. So obviously this is not the approach that you would take when creating a basic XNA Windows game. But again, I just thought it would be valuable for you guys to see all of the pieces kind of plugged in together outside of the template that's provided. So just so you can see it all working. Anything you want to add to that, Logan?
Nothing really. Like you were saying, the whole point of this was just to take any of the magic out of creating an XNA game from the template.
Yep.
Showing that one can indeed create a working game very easily just by extending the game class and then running it.
You got it. So with that, that is going to wrap up this video. Thanks a lot.